Bismillahirrahmanirrahim. We'll start 9.8. Yeah, I will delay 9.7 with 9.10. So we'll start 9.8. What we have in 9.8? Power series. What do they mean by power series? X is a variable, X is a variable. Then an infinite series of this form. An x to the power n. A0 plus A1x plus A2x squared. This is, they call it what? Power series. This is if it is around, it's working with x minus 0. It's working with, we can expand it to a power series centered at c, where c is a constant. So we have an x minus c all to the power n. So it's A0, A1, x minus c, A2 plus A2, x minus c square, and so on. Okay. This is the power series centered at what? Centered at 0. Since I have this one, I can write it x minus 0 all to the power n. This is what they meant by centered at 0. This one centered at what? This is what? X minus minus 1. So centered at c equal minus 1. This one centered at, very clear, at 1. It's x minus 1 all to the power n. All of these three are power series, but centered at different value. Okay? So power series may converge for some values of x, and may diverge for other values of x. Well, you need to check for x, any x will check what will happen. And c is called the coefficient of the series, and the c ends this. The sum of the series is the function. Actually, this is the function of x. Okay, what's the domain of this function? It's the set of all x for which the series converges. This is very clear, is the polynomial. That f has infinitely many terms. Polynomial with infinitely many terms. And that's mainly the idea of all of these sections, 9.7 up to 9.10. The main idea is what? I have a function. Usually these functions, exponential, trig, inverse trig, logarithmic functions, not easy to deal with. But the easiest function to deal with is the polynomial. So because of that, I want to rewrite these functions in terms of polynomials with infinitely many terms. Okay. I'll say this is a function of x, but I can write it this way. What's the domain? Where the values of x, where the power series what? Converge. Very clear. X equals c, which was the series is centered at, the power series will converge at c. So c is in the domain of f. Why? Because if I write c, then I have 0, 0, 0, 0. The first one will be a0 to the power 1, but the rest will be 0. So f of c is defined. Now, when we talk about power series at c, we have one of these three possibilities. Either the series converges only at c, or the series converges absolutely for all x, or it will converge for an interval with x minus c less than capital R. They call R the radius of convergence. And the interval, which we get, now if we solve this, I have x minus c, t minus r and r. So x between c minus capital R and c plus capital R. This they call it interval. And also we need to check the endpoints. So I have either converges only at c, or converges for all x, or converges for an interval, and diverges for the other things. So if it is converged for x minus c less than r, it will converge, diverge for x minus c greater than r. In this case, the radius of convergence would be 0, because there is nothing. We have only a point. In this case, the radius of convergence is infinity. In this case, the radius of convergence is r. And the interval will find out. And this one, the interval will be what? Minus infinity up to infinity. This one, just the point. This one is an interval by itself. Okay. Find the radius of convergence of this. Usually, what we will do, Usually we use the ratio test. Sometimes we use the root test, but mainly we use the ratio test. And we know that for the ratio test, I have the limit n goes to infinity, an plus 1 over an. And what will control this? I need L to be less than 1. That's it. That's what will happen. Okay, so let me find this. I have the ratio test. L will be limit n goes to infinity, an plus 1 over an. That will be limit n goes to infinity. This is what n plus 1 factorial x to the power n plus 1 over n factorial x to the power n. And that will be what? Limit. That will be limit n goes to infinity. N goes to infinity of what? This is what? This is n plus 1 times n factorial. So this is cancelled. So I have n plus 1 times x. If you apply the derivative, what you will get? You apply the limit, I mean. You have infinity, x is fixed. So that will be infinity. That's impossible to be less than 1. So it means what? This series. So I have which case? I have this case. This series converges only at C. This series converges only at its center, which is 0 in this case, since I have x minus 0. Okay, so which is 0. And so what is the radius? What is its radius of convergence? Is r equal 0, which is we have the first case. Because this infinity always greater than 1. Okay. Let me do this one. Find the radius of convergence. We'll do the same thing. I'll write L, L, the limit n goes to infinity, an plus 1 over an. That will be limit n goes to infinity. What is that? 3 x minus 2 to the power n plus 1 over 3 x minus 2 to the power n. That give me what? 3 cancelled. I have the limit as n goes to infinity of x minus 2, which is absolute value x minus 2. There is no n here. So this is less than 1. I want this less than 1 for convergence. So I have an interval now. So I have what? X minus 2. What is R? For sure, R will be 1. Because if you remember, this is what we said. They have X minus C less than R. Okay. So R equal 1. And the interval is what? X minus 2 less than 1. Or x minus 2 between minus 1 and 1. You can say x less than between 1 and 3. Actually, I need to check later. We'll say that. We check endpoints too. And that's what we'll discuss later. But now, for the time being, just I want you to know this. Find the radius of convergence for this one. Do the same thing. What is the limit? N goes to infinity, which is L, an plus 1 over an. What will be that? That will be limit n goes to infinity of what? Minus 1 to the power n plus 1, x to the power, be careful here, 2 n plus 1 plus 1. Every n plus 1, every n I take it n plus 1. And this is will be 2 n plus 1 plus 1 factorial times the reciprocal of this, which is 2n plus 1 factorial over minus 1 to the power n x to the power 2n plus 1. Okay, so let us see what will happen. That will be limit n goes to infinity of what? this with this, I have a minus sign with the absolute value. This will be gone. This is what? 2n plus 3 minus this. I have x to the power x squared over. This is what? 2n plus 3 factorial. 2n plus 3 factorial. And this is 2n plus 1. If you notice, this is what? This is 2n plus 3. 2n plus 2 times 2n plus 1 factorial. So this is cancelled. So I have here 2n plus 3 times 2n plus 2. X is a fixed number. So I have a number over infinity, and that will be 0, which is always less than 1. So the series converges what? Series converges for all x. So what is R? Capital R? Infinity. So we're in the third case, where we are here. Tables between minus infinity to infinity. All values are fixed. So we have all the three cases. R equals 0, interval. As I said, the interval, we need to check the endpoints. That's what we'll do later. And also converges for all x. Now, let me do more problems. Find the domain of this function. We call it Bessel functions. What we'll do, well, this is just a series. Deal with it as a series. So I need L limit n goes to infinity, an plus 1 over an. Okay, that will be what? Limit n goes to infinity. That is minus 1 to the power n plus 1, x to the power. Instead of n, I write it n plus 1, so 2n plus 2 over 2 to the power. Be careful here. 2n plus 2 also. N factorial, which is n plus 1 factorial all square. Times first miracle of this. Do the calculation like what we did here. I'm checking. I have a limit always. You need to don't forget the limit. Then you get rid of all ends. This one, on this one, I have a minus sign. That will make nothing because of the absolute value. This will be x squared. Now this with this, I have 2 square here. Now n factorial, it's what? N factorial, n factorial. And this is n plus 1 factorial, n plus 1 factorial. So I have n plus 1, n plus 1. Because this is n plus 1 times n factorial. Cancelled. And the same thing with the other. So I have n plus 1, n plus 1. So what I have the limit, I have a number over infinity, that will be 0, which is always less than 1. So this series converges for all x. That means what is the domain of f? The domain of f of x is minus infinity up to infinity. Because we say the domain is the set of all values of x where the series converge. Okay. If I have a finite number r, it's really saying nothing about the convergence at the endpoints. So we need to check these endpoints separately. And by the way, we cannot use the ratio test. I need to do other test. So then the interval either will be a point or minus infinity to infinity, where r equals 0, and this is r equals 0 and r equals infinity. If you have r, then it's either like the open interval, open close from one side, close from the other side, or close from both sides. So you have these 6 cases. Find the interval of convergence. Notice here I need to find the interval of convergence. Before he bought only the radius. The radius, I don't care about the endpoints because the endpoint will not be affected. Let me do this one. We'll do the same thing. L limit n goes to infinity, an plus 1 over an. That will be limit n goes to infinity. What is that? xn plus 1 over n plus 1 times, I have a reciprocal of this, n over x to the power n. So I have a limit n goes to infinity of what? X times n over n plus 1. That will be limit. That will be x. X will not be affected by the n, so take it away. Limit n goes to infinity. Yeah, absolute value of x. N over n plus 1. What is the limit of this? Same degree, so it's 1. So I have absolute value of x. For convergence, I need what? Less than 1. So that means x is between -1 and 1. Now what I will do? Check endpoints. Check endpoints, which is -1 and 1. X equal -1. What will happen? I have summation n equal 1 to infinity. -1 to the power n over n. What is this? This is alternating harmonic. So converges. Okay. Check x equal 1. What you will get? Summation n equal 1 to infinity, which is 1 over n. 1 to the power 1 will be 1. That's harmonic. Harmonic series, which is what? Diverges. So it will be the interval convergence. It will be this. But at -1, converges. So I have equality here. At 1, we don't have convergence, so we'll leave it open. So the interval close -1, open 1, which is this one. Let me check this. Now, same thing. Find limit n goes to infinity. This is what? -1 n plus 1 x plus 1 to the power n plus 1 over 2 n plus 1 times the spherical of this. Okay, that will be limit. This is -1 cancelled with absolute value gone. I have x plus 1 over 2. Am I right? Yeah. So I need this to be, which is absolute value x plus 1 over 2 less than 1. So absolute value of x plus 1 less than 2. So my capital R, by the way, is 2. Huh? Here, what is R? R is 1. Huh? Since this is R equal 1. So just for the information. Yeah. So I have what? X plus 1 is between -2 and 2. So that implies x between -3 and 1. Okay. So now I'll check. Now check endpoints. Check endpoints. X equal -3. See what will happen. So I have the series n equals 0 to infinity, -1 to the power n. What is that? -3 plus 1, which is -2 to the power n over 2 to the power n. And that, if you combine it, it will be n equals 0 to infinity. That's everything to the power n. -1 times -2 is 2 over 2. That will be, it will be 2 to the power n over 2 to the power n, which is 1. I know this series is what? Diverges. 1 plus 2 plus 3 plus, yeah. 1 plus 1 plus 1 plus 1 plus 1. For sure, it will be diverging. Now check the other point. X equal, what is it? 1 is -3, the other one is 1. So I have what? I have the series n equals 0 to infinity, -1 to the power n. 1 plus 1, this is 2 to the power n over 2 to the power n. This is cancelled. So I have what this series. I know also this series is what? Diverges. Because I don't know its limit. Yeah, by the way, this is not only because that the limit will be 1, huh? By the int, this is the limit of 1 equal 1, not equal to 0. So by the n term of the divergence. N term for divergence, huh? N term test for divergence. The same thing here. For the same reason, because the limit will not be 0. The limit does not exist. So not equal to 0. So what will be the interval of convergence? Both terms are both endpoints are diverged. So will minus 3 to 1. Okay. Let me check this one. Find the interval of convergence of this one. I think now the idea is very clear. Just we need to check. Now just we need to do examples. Yeah. Okay, same thing. We'll find L limit n goes to infinity, an plus 1 over an. That will be what? Limit n goes to infinity, x to the power n plus 1 over n plus 1 square times n square over x to the power n. That will be limit n goes to infinity. What is this? X times n square over n plus 1 square. And that will be absolute value of x times this limit, which is n square. No need for the absolute value. Yeah. It's very clear it will be the same degree with I'm getting 1. So it's the absolute value of x times 1, which is the absolute value of x. And when this is less than 1, so I have x between minus 1 and 1. Now check endpoints. X equal minus 1. What will be the series? Minus 1 to the power n over n factorial. Yeah, you can check this alternating series. Converges. Very clear, the limit goes to infinity and it's decreasing. The other endpoints, x equal 1, what will be the summation? 1 to the power n, which is 1 over n square. This is B series. Converges since n equal 2. That converges. So what will be the interval? Interval of convergence. Both are included. This included and this included, because both converges. Closed, minus 1 and 1. So you have one closed, both open, one closed. Now, I think the idea is very clear about this section. Now we are doing some examples. Okay, what would one expect? Does the series converge? Okay, let's do the same. L will be limit n goes to infinity, x minus 3 to the power n plus 1 over n plus 1, reciprocal of this. Okay, by the way, here r is 1, huh? R equal 1, which is this one. Yeah. Because usually they ask about either the interval of convergence or the radius of convergence. So that will be equal what? Limit n goes to infinity of what? X minus 3 to the power 1, huh? N plus 1 over minus n times n over n plus 1. Don't forget this. This is the limit 1, so you have absolute value x minus 3. I want this to be less than 1. So what will be r? R will be 1. What will be the interval? X minus 3 or x between 2 and 4. Now check endpoints. See what will happen. At x equal to what I will have. This I know this series converges. We call it alternating harmonic, if you remember it. It will be converging. X equal 4. What you will have? Summation 4 minus 3, 1 to the power n. That will be 1 over n. So this is diverges harmonic series. Harmonic series. So the interval will be what? 2 is okay, but 4 is not. Or so this is the values of x where the series converge. Or I can write it as an interval close to open form. Yes. This one, let us do the calculation. I think we did it. X to the power n over 2 n factorial. It's similar to this one. Okay. And this is what will happen exactly. Okay. So we have L will be limit n goes to infinity, an plus 1 over an. That will be limit n goes to infinity, x to the power n plus 1 over 2 n plus 2 factorial. Spherical of this. That will be limit x over here 2n plus 1. We did something similar. And that is equal to infinity. No, that will be 0, sorry. That will be 0. Because it will be x over infinity, which is 0, which is similar to this one. Similar to this one. Yeah, you have x over n. So r, which is less than 1, always less than 1. So r equal infinity, the interval, the series converges for all x values. We can find the interval. We can write minus infinity up to infinity, which we have all the x values. Okay. For the radius of this one, we are doing more examples. So I'll find L, limit, n goes to infinity. I will not write it again, huh? Or right away I will go to this. Limit n goes to infinity, n plus 1, x plus 2 to the power n plus 1 over 3, n plus 2, with n plus 1 plus 1 times the reciprocal of this. Right away. That will be what? Limit. I have n plus 1 over n, which I know it's 1. The limit is 1. This is times 1 over 3. This with this. And all of that times what? 1 over x plus 2. Is it? No. Times x plus 2. Yeah. Because this with this, give me x plus 2. This limit is 1. This is 1 over 3. So the limit will be x plus 2 over 3. I want this to be less than 1. So I have absolute value x plus 2 less than 3. So r equal 3 in this case. Okay. Find the interval x plus 2 between minus 3 and 3. Or I can say x minus 5 and 1. Yeah. So now check in the points. X equal minus 5. What will be the series? N minus 3 to the power n over 3 to the power n plus 1. Okay. Is it? Yeah. And that will be summation n equals 0 to infinity minus 1 to the power n times n over 3. Yeah. Is it? Yeah. I have n x equal minus 5. So I have minus 5 plus 2, which is minus 3 to the power n. Take minus outside. I have 3 to the power n. Let me do it in steps. This is n minus 1 to the power n, 3 to the power n over 3 n plus 1. And that will be summation n minus 1 to the power n over 3. What will happen to this series? Diverges. Yeah, diverges. Let me write it here. By n term test for the divergence. The limit will not be 0. The limit of this will not be 0. Does not exist, but it will not be 0. Okay. Now check the other endpoints. X equal what? What it was that? X equal 1. So it will be the series n 3 to the power n over 3 to the power n plus 1. And that will be summation n over 3. Same thing, diverges by n term test for divergence. So what will be the interval of convergence? Minus 5 and 1, both of them. As we said before, the ratio test or sometimes the load test shall be used to determine. Always fail when X is an endpoint. So the endpoints must be checked by some other test. Okay, so let me do this. Minus 3 to the power n x to the power n. See what will happen. I have, yeah, let me find L. Limit n goes to infinity. This will be what? Minus 3 to the power n plus 1. X to the power n plus 1. Square root n plus 2 times reciprocal of this, square root n plus 1 over minus 3 to the power n, x to the power n. Yeah, this limit will be what? Limit n goes to infinity. Minus 3, which is 3. The minus sign will be gone. I have x times this. Very clear this limit is 1. Huh? So this one will be absolute value 3x less than 1. So I have absolute value of x less than 1 over 3. So r equal 1 over 3. Okay. So x minus 1 over 3 and 1 over 3. Now let me check minus 1 over 3. Check the endpoints. I have what? Minus 3 to, so it will be the series. Minus 3 to the power n minus 1 over 3 to the power n over square root n plus 1. That will be what? Minus 3 times, since the same power, that will be 1, which I know is divergent. You can compare it with square root of n, huh? Yeah. Divergent, x equal 1 over 3. What you will get? 1 over 3 to the power n over square root n plus 1. That will be summation. Now it's minus 1 to the power n over square root n plus 1. It's alternating series where it's converge. Yeah, so the interval. By the way, r equal what? 1 over 3. I already wrote it. It's okay with 1 over 3. And not okay with the negative. So that would be the interval. Okay, yeah. Let me do this one. I think we did it. Yeah, this one we did. So no need to do it again. We did it, I think. We did done before. Okay. This one. So this is really my series. So this is the series of minus half to the power n. That will be the enter. X minus 2 to the power n, where n is running from 0 to infinity. That's what I want to work out. So L, that will be my an. Limit n goes to infinity, minus half to the power n plus 1, x minus 2 to the power n plus 1 over an. So that gives me what? Limit n goes to infinity, half. Okay. This is what? X minus 2, which is x minus 2 over 2. I want this to be less than 1. So I have x minus 2 over 2 minus 2 and 1. So r equal 1. Huh? So this one will be what? X minus 2 between minus 2 and 2. So x between 0 and 4. Check endpoints. X equals 0. You have what? Summation n equals 0 to infinity. Minus half to the power n. Minus 2 to the power n. Which is 1. Diverges, we know it. Interim test of divergence. X equal 4. What will be that? Summation minus half to the power n, or minus 2 to the power n. That give me minus 1 to the power n, which is also divergent. So the interval 0 to 0. Okay. Yeah. Okay. Yes, it's a geometric series, very clear. The first term is 1 and r is x minus 2 over 2 to the minus. Okay. Does the following series converge or diverge? I think we did something similar. Yeah. Yeah, let me stop. I'll stop the recording, then I'll continue in the next video. I think the idea is very clear. Yeah. Thank you.